My dissertation work was in the Franklin Mountains, and I've got a sort of a summarized section here we'll look at today. It's really the lower division in the El Paso group in the Franklin Mountains in El Paso, Texas. The middle division is missing here, so the entire section group is not present. Whether it was eroded or never deposited, we don't know. It's just not there. And then, but generally, what we're looking at is we're going to focus really on the El Paso group down here and what's going on in the karsting in this zone, and then we'll talk a little bit about what's going on above that as well. And one of the key points I want to touch on that Charles mentioned is that, one of the things with these karst systems is they're commonly stacked. So you're going to see reactivation, and sometimes it's fairly quickly, within a few thousand to tens of thousands of years, and sometimes it can be reactivated over millions of years later. So it's a complex thing. Karst happens where it wants to. Is kind of the end of the story there. So what I want to take you through is this next slide here. This is a traditional geological map, right? On the left-hand side, you've got your contacts, you've got the red lines, which are your faults. Sorry, I get crazy with that. You got your red lines that are faults, you got your geological contacts, and this sort of gives you a picture of what's going on. I'm sure most of you could look at that pretty quickly and say, all right, we've got sort of a homoclinal dip going to the west, and it sort of more or less goes northwest, southeast, and we get a pretty good picture of what's going on. The purpose of the project that I got involved with was to try and map in 3D. So instead of making a traditional geological map with, a piece of paper and pencil and brunt compass, I said, okay, those things kind of get a little bit, sometimes lose some of the detail that's important. And when dealing with something as complicated as karst, mapping in 3D gives you a much broader canvas to work with. So I went and collected some airborne Lidar data. I'm just going to play this in the background while I talk. Give me a second here. Turn off the laser pointer. Is that moving? Good. All right. So I'm just going to talk to this and let it play through a few times. So what we have here is we're looking at the dip slope from the west. So here's the western dip slope of the El Paso Mountain. This scale of this project is about 10 sections, roughly 10 square miles. So it's a pretty large area. I mapped every single contact with GPS on foot, so nothing is interpolated. Really, almost nothing is interpolated. I watch every contact. The orange bodies you see as we're scrolling by, they're sort of in the middle of the screen. Those are the breccia bodies that were mapped out. And the various colors, the purples and pinks you see, those are in the Montoya and the upper Ordovicians. Those are sitting above the South Tippecanoe unconformity. And we see the yellows poking through. That's places where the erosion on the dip slope has cut down into the upper part of the lower Ordovician. So through the unconformity, showing a little fenster of what's going on below. As we rotate around the north end of the mountain, you can see the stratigraphy sort of laid out. So the red yellow and the sort of peach color are the upper part of the lower Ordovician, and then the greens, the two shades of green, are sort of the middle lower Ordovician, and then the blues are the lower part of the carbonate section of the lower Ordovician. And again, the oranges are your karst bodies. You can start seeing those as we rotate around. So you get a good picture of what's going on. If you're in a helicopter, which is how we acquired this data, you can see the homoclinal dip to the west, and you can also see that the outcrop is basically, dipping up and giving you a nice vertical succession. But of course, you're distorted in 3D because you're looking at the oblique angle or relative thickness of what's going on. So one of the beauties of collecting 3D data is that you can then take the data after you've mapped it, you can flip it into depositional orientation and look at everything embedding on, and sort of get a feel of what it really looked like. So what we'll do here is we'll just pivot this model, and I'll turn it a little bit to your right, and then we'll dip it up so you're looking straight on the actual original deposition. So it's sort of like a true cross section as it was deposited. And again, the red lines are faults. And so here we are, we're taking out the distortion, so you can see your karst bodies, how they really kind of marry up to that gray to yellow transition here. So that's the upper Ordovician here, lower Ordovician here. The black line between those two is the unconformity with the missing middle Ordovician. Some of these karst bodies you see come all the way down towards the bottom of the Ellenberger. So that's an example there where we're drifting past it. You can see there's a big karst body near the base, and you get a second one up here. And as we rotate around the backside again, you'll see there's actually some upper Ordovician karst that are sitting on top of that. So you've had obviously multiple episodes of karsting. The exact timing of these is really tough to nail down for various geochemical reasons. I've looked at doing isotopes and things like that, and it really is rather complex and would be a whole other PhD in itself. So I kind of stopped here on this one. But again, you can see some of the linear faults mapped in here. I'm going to start the movie one more time so we can kind of talk through it because it's a lot to absorb. But you can see these red lines and the linearity of that going north, sort of northwest, south, northeast, southwest. And look at these karst bodies following right along that linear pattern. You don't get the vertical exposure that you do on the east face on the dip slope, but you see the linearity of that really consistent. And again, these were walked out. I mean, I literally walked with GPS and walked every contact. The beauty of mapping in 3D was that I was able to then put these things in context and start playing with the geometries, looking at some of the structural orientations and what's going on. And as the paper in the Great American Carbonate Bank goes through a lot of that in detail. I won't bore you with all that right now, but there's some interesting things timing-wise with multiple reactivation of the karst system in this area. So you had numerous events of karsting going on. You can see by the fill and the mineralogy of the fill in each of these different karst bodies that they've gone through different phases of diagenesis. But getting back to the reservoir part, the real key, and I think this was played out quite well in some of Laux's work and some of the things that you talked about today, is that the lion's share of your porosity is not going to be necessarily inside these karst bodies. It's actually mostly fracture porosity around and above these collapse structures. If you drill a well often through the breccia itself, you'll find it to be rather tight. A lot of clay fill, a lot of mineralogy. You offset that well by a few hundred feet, and you get into a nice section of fracture porosity where you get a really sweet well, whereas the one that you may have drilled right through the heart of that karst body would actually be pretty tight, pretty cruddy. So that's kind of the takeaway. And it doesn't have to be, of course, the soft tip canoe. This is a global thing. You see unconformities all throughout the geological record, and you see these karst systems developing on multiple of these. I see these things in Oman and Kazakhstan, different fields around the world. So this is a pretty common occurrence. So Charles brings it up, I think, quite appropriately, that this is another way to sort of think about what's going on with unconformities. And with that, I will love to entertain any questions or questions for Charles. I know we're probably just about out of time, so but I'll be here for the next couple hours when he wants to talk or throw a question out now.
So the next southwest section means going to El Paso, Franklin Mountains are right in the backyard.
All right, thank you guys. I'd like to present you with a token of our appreciation. And